Welcome to Pharmoglory TV. So in today's lesson, we'll be tackling some calculations in pharmaceutical analysis, specifically on the inspection of impurities in drugs. So let's quickly get into it. So just a brief introduction. So what are impurities in drugs? So what are impurities in drugs? So impurities are any unwanted substances introduced during the production of drugs and the storage of drugs. Okay, so in other words, we can say an impurity is any substance or any unwanted substance that affect the purity of drugs. Okay. So these impurities have no therapeutic effect. They have no therapeutic effect. So secondly, they affect the stability of drug. They affect the stability of drugs. Thirdly, they also affect the efficacy. They also affect the efficacy of drug. Fourthly, they can also be harmful to human health. They can be harmful to human health. All right, that is why the inspection of impurity is important. So let us quickly look at some importance of impurity inspection. So some importance of impurity inspection. Okay, so number one is to ensure the quality of drug. To ensure the quality of drug. Secondly, to ensure the safety of drug. To ensure the safety of drug. Thirdly, to ensure the stability of drug. Then fourthly, we can say to also ensure the effectiveness of drug. The effectiveness of drug. Okay. So the effectiveness of drug. So these impurities are substances which are not required in the drug. So sometimes, usually they are introduced in drug in the production process as well as the storage process. And sometimes they can be due to microorganism or due to external temperatures or due to any condition that they might be subjected into. However, if they exceed a certain amount of their allowance in drug, then they can damage the effectiveness of that drug, and if they are administered to patients, they may be so harmful. That is why we need to now check for their limit. We need to check for their maximum limit. Like we need to have the maximum limit of these impurities in drug. So today we'll be focusing, our calculation will be focusing on calculating, understand what impurity limit is. What impurity limit is. So what impurity limit. So what impurity limit is. So impurity limit is simply the maximum allowable amount of impurities in drug. So the maximum allowable amount of impurities in drug is what is impurity. And it is usually expressed in percentage or it is expressed in ppm, which is parts per million. Okay. All right. So in calculating the impurity limit, we have three methods which we can use. The first method in calculating or determining this the impurity limit, the first method, the most common one, which is the control method. The control method. Control method. All right. So the second method is the sensitive method. So sensitive method. All right. So the third method we can use is the comparison method. So the comparison method. Okay. So, however, in today's calculation, usually we work on, this is the most important one, the control method we usually use in determining the limit impurities. Yes. So today we'll focus more on the control method in determining the maximum allowable amount of impurities in drug. All right, so this was just a brief introduction to impurities. So let's get into the calculations. All right, okay, so the equation of impurity limit is simply equivalent to the standard concentration of the solution by the volume divided by the amount of drug being tested. Then the entire result, we can multiply it by 100%. So in abbreviation format, we can say L stand for impurity limit, then C stand for the concentration, V stand for volume, S stand for the amount of drug being tested, then multiplied by 100%. All right, so let's get into the question. So now let's try to get our information from the question, then we're going to substitute them into our equation. So let's write our data here. So let's get concentration, the value of concentration. We know that concentration is equals to mass over volume, which is equivalent to density. So in this case, and concentration is the standard concentration of the solution. And from the question, we are checking for the inspection of chloride in paracetamol. So we took 2 grams of paracetamol, then we added 100 millimeters of water, we heated it, cooled, filtered. Then out of that 100 millimeters of paracetamol, which has completely immersed or dissolved in water, we only got 25 millimeters out of 100. Then that 25 millimeters was the one which we checked for the chloride content according to the Chinese pharmacopoeia law. Okay, then now the volume which we had was 5.0 millimeters of standard chloride solution. So now in brackets, now they've given us the standard concentration, which is, they are saying every 1 millimeters is equivalent to 10 microgram. Okay, to 10 micrograms. So now since we know that mass over volume gives us concentration or density, so now they've given us 10 microgram over volume, which is 1 millimeters. Okay, so now the concentration here, the concentration which we have, which is 10 micrograms per millimeters, once we divide that. So this is our concentration, which is 10 microgram per millimeters. All right, let's calculate our volume. So our volume, they've already given us, which is, our volume is 5.0 millimeters. So our volume, which is 5.0 millimeters. Okay, so we also have our volume. Let's calculate for the amount of drug being tested, which is S. Okay, so as we can see from the question, so 2 grams of paracetamol was completely dissolved in 100 millimeters of water. However, we did not test the whole amount of the drug which was submerged in water or dissolved in water. We only took 25 out of 100. So we only took 25 out of 100 millimeters of drug which was dissolved. So now we had used, that was 2 grams. So now to this will get the exact amount of drug which was being tested. So now once we multiply 2 25 by 2, we have 50. 50 divided by 100, we're going to have 0.5 grams. Okay, now so we also have our S, so we can just get these figures and replace them into our equation. All right, so now we know that the limit is equals to concentration multiplied by volume divided by the amount of drug being tested. Then we can multiply the result by 100. So we have our concentration, which is 10 micrograms per millimeters, multiplied by the volume, which is 5.0 millimeters. Okay, so we can divide all these things by the amount of drug being tested, which is 0.5 gram. However, as you can see, so now the result will multiply it by 100%. So as you can see, the concentration is in micrograms per millimeters, but the amount of drug on the bottom is in grams. So we need to convert either the concentration, this concentration, we can convert it into grams per millimeters, or we can convert the value on the bottom from grams to micrograms, so that the units on the bottom, on top and on the bottom, will be able to cancel each other, so that the value of impurity limit shall just be in percentage. Okay, so we know that 1 gram is equivalent to 1 million microgram, which is simply 10 to the power 6. All right, so now let's say you want to convert a value from grams to microgram. So let's say if you want to convert grams to micrograms, so this is what you can do. Let's say you've got 1 gram, you've got a value in gram, you want to convert it into micrograms. So what you can simply do is just to multiply the value in grams, you multiply it by 1 million microgram per gram, so that gram and gram will come and cancel. Then when you multiply the value by 1 million gram, you're going to have, which it will just give us 10 to the power 6 microgram. Okay, so if you want to convert micrograms into grams, so let's say you've got 1 microgram, you want to convert it into grams, you can simply multiply it by 10 to the power negative 6 grams per micrograms, so that this microgram and this microgram will come and cancel. Then when you multiply the value by 10 to the power negative 6, then to give you, that is the value in grams, which will simply be 10 to the power negative 6 grams. So this is the simplest way on how to convert these our units. All right, so let's get back to the question. Okay, so now since we said that we want to convert 0.5 into micrograms, so we'll use this principle here. We'll use this principle here. Okay, so I'll just multiply 0.5 gram by 10 to the power 6. Then that will be micrograms per gram, so that if we cancel the units, this gram will cancel and that other gram will cancel. Okay, let me change the color. Okay, so this will cancel with that gram. Then on top, we've got the millimeters will cancel with the millimeters. Then this remaining microgram will come and cancel with this microgram. Then don't forget that here we've got times 100%. So meaning our final value for the limit will be in percentage. As we said, limits are expressed in percentage or parts per million or particles per million. All right, so now all we've got to do is just to punch everything into our calculator, so that is if I use my calculator, that is 10 times 5 divided by 0.5 times 10 to the power 6. Then my answer, then I'll get this answer and multiply it by 100. The answer is 0.01%. So, therefore, our chloride limit in paracetamol is equals to 0.01 percentage. So this is our chloride limit. As we said, limit or impurity limit is expressed in percentages or in parts per million, which is also like particles per million. So this is our values. So just in case you are still having challenges in terms of converting the units, you can leave a comment in the comment section below, and I'll be able to see if that is necessary. Then I'll make a video separately for just unit conversion. All right, so let's go into the next question. Okay, so you can pause this video and try to work out on this problem. Then once you are done working out on it, then you can try to unpause the video and try to see if your solution and my solution is the same. Okay, so first of all, let's write our equation. So we know that limit is simply equals to the concentration multiplied by the volume divided by the amount of substance being tested multiplied by 100%. Okay, so let's get our data together and we're going to replace our values into the equation. We can start with concentration, of which we know concentration is equals to mass over volume. Then the concentration is usually given, that is in brackets, as we can see. So they're saying every 1 millimeter is equivalent to 10 microgram of lead. So grams, which is 10 microgram, divided by the volume, which is 1 millimeter. So this one, it will give us 10 micrograms per millimeter. So that is our concentration. Okay, so we have our concentration. Then let's calculate for for the volume is what they want us to calculate, so we don't have the value. Then the amount of substance being tested. Okay, let's see now from the question. So this is slightly a little bit different from question 1. As we can see here, we took 4.0 gram of glucose. Then in this question, we have seen that we are testing the entire 4.0 gram of glucose. We are not like dissolving it in water. Then once we dissolve it in water, then we get a specific amount of glucose or amount of solution, which we proceed into checking the heavy metals into it. No. In this kind of equation, we took 4 grams of glucose, we dissolved it with 23 millimeters of water, then we added 2 millimeters of acetic buffer solution and checked. So we are checking the entire glucose. We are not getting a specific amount of solution which we are checking for the heavy metals. So in this kind of a case, we are just using our 4.0 grams. So there will be nothing like trying to multiply of anything. We try to check the specific amount of anything. No, in this kind of equation, it is direct and straightforward. So we have our values, and now they're also saying the content of heavy metals should not exceed 5 parts per million. And we said our limit is expressed in percentages and in parts per million. So now they've given us also the value for the limit. So limit is equivalent to 5 per million. 5 per million, that simply means per million, and we know 1 million is equals to 10 to the power 6. So 5 per million. This is the same as 5 times 10 to the power negative 6. It is the same thing. So 5 parts per million, which is the same as 5 times 10 to the power 6. So these are our values. So what we can do, we can just, from our equation, we can simply make volume the subject of the formula and replace the values and calculate for V. So let's get into it. So what we can do, we know that limit is equals to concentration by volume by the amount of substance being tested multiplied by 100. And now we know that 100%, converting this 100% into a decimal fraction is just 1. So 1 multiplied by everything, it will just give us 1. So we can just leave out the 100%. Okay. So now let's just make V our subject of the formula. So what we can do, we can say over 1, we cross multiply and multiply. So 1 by concentration by volume, it will give us concentration times volume is equivalent to limit times the amount of substance being tested, which is equals to limit by the amount of substance. When we divide both sides by concentration, this concentration and that will cancel, then our volume is going to equal to the limit by the amount of drug being tested divided by the concentration. As we saw that percentage, we had already converted the percentage into fraction, which just gave us 1. Okay, so now we can just replace the value and get the value we are looking for, which is the volume. All right, so our limit we already have, which is 5 times 10 to the power 6, which is 5 parts per million, multiplied by 4.0, and this one is in grams. Okay, so divided by concentration, which is 10 micrograms per millimeters. Okay, so now you can decide which value you want to convert. Is it 4 grams you want to convert it to micrograms, or the value on the bottom, which is in microgram, you want to convert it into grams? So what I'm going to do, I'm going to convert grams into micrograms. So I'll just simply multiply just on top, which is 10 to the power negative, or 10 to the power 6, then that is microgram per gram. Okay, so that it will be the units here, which will be micrograms per gram. Okay, so later on we are going to discover that microgram, let me change the color again. So we're going to discover that microgram and microgram will come and cancel, then this gram and that gram will cancel each other. Then later on we'll only remain with the volume, which is the volume we are calculating for. Okay, which is the volume. So now therefore our volume is equals to, so all we've got to do is just to punch everything into our calculator and solve nicely. So once we solve, that is 5 times 10 to the power negative 6 multiplied by 4, then that's my value. If I multiply by 4, again multiplied by 10 to the power 6, then divided by 10, it will give me 2. So our volume is equals to 2 millimeters. So this is our final value. I hope your value and my value is the same. Okay, so let's do the last question. Let's do the last question of this. Okay, so try to pause this video and work out on this problem. Then later on you can unpause and try to confirm your answer with what we're going to calculate here. Okay, so let's get into the question. So this is the inspection of methanol in ethanol. Then let's quickly go through the question. They're saying take 2 milliliters of ethanol, dilute it in 50 milliliters of water, separate 1 milliliter, then add 0.2 milliliters phosphoric acid solution and 0.25 milliliters of 5% potassium permanganate solution. Keep temperature at 30 to 35 degrees for 15 minutes. Drop 10% sodium pyrosulfite solution until colorless. Slowly add 2 milliliters of ferric acid solution. Cool in ice bath, then add 0.1 milliliters new 1% chromotropic acid solution and heat in water bath for 20 minutes. If the color development is compared with the volume of 2.0 milliliters of standard methanol solution, precisely weigh 20 milligram of methanol. add water to make 200 milliliters, and the control solution made by the same method should not be concentrated. Calculate the limit of methanol in ethanol. And this is the special question. As you can see, the limit, they've told us that the units, they want the units to be in grams per milliliters. So that simply means we will not be able to use our percentage our limit shall not be expressed in percentage, neither will it be expressed in parts per millions. This one is a kind of a special question because we are testing the liquid which is in volume. Okay, so let's get into the question. So first of all, we can write our formula for limit. So limit is equals to concentration times volume over the drug being tested multiplied by 100%. However, due to our question, we are not going to express it in percentage. So that simply means we're going just to use this section here, due to our unit. Okay, so let's try to get our data. So our data. Okay, so let's start with concentration. Concentration, as we can see, it has already been given to us in brackets, which is in brackets here where they are saying precisely weigh 20 milligram of methanol, add water to make, so which is its corresponding volume, which is 200 millimeters, and we know it's mass over milliliter, so mass over volume, so that is 20 milligrams over 200 milliliters. Okay, and so what we can do in this kind of a question, we can try to also maybe convert 20 milligrams into grams, so that we just make our entire work easy. And it is very simple, just as we did the other question in converting the units. So what we can do, we know that 1 gram is equivalent to 1000 milligrams. Okay, so if you want to convert grams to milligrams, you can just get your value in gram. Let's say you have 1 gram, you want to convert it into milligram. So the only thing you can do is just to multiply it by 10 to the power 3, or 10 to the power 3, or you can just multiply it by 10 to the power 1000. Then in order, because we want to convert this gram into microgram, so what we can do is going to be microgram per gram, so that the gram on the bottom and the gram to 1 shall cancel each other, and we're going to have, so this gram and that gram will come and cancel each other, and we're going just to remain with 10 to the power 3 microgram. Okay, which is the same if you want to convert micrograms into grams. Okay, so let's say if you've got 1 microgram, you want to convert it into grams. So what you can do is just to multiply it by 10 to the power negative 3. Yes, 10 to the power negative 3, because we want to cancel milligrams. So what we can do is going to be grams per milligrams. So that and that will come and cancel. Then the value, which is, let's say 1 in this case, multiplied by 10 to the power negative 3 is going to give us 10 to the power negative 3 grams. So this is how simple it is. Okay, all right, so let me just, okay, so we can proceed. So in this case, we want to convert micrograms into grams. So what we can do, we can simply just multiply this value by 10 to the power negative 3. Then it's going to be grams per microgram, so that this gram and that gram will cancel each other. So when we get our calculator, okay, let me just rewrite everything here. So it's going to be 20 by 10 to the power negative 3 gram divided by 200 milliliters. Okay, so our concentration, so therefore concentration is going to equal to let's just calculate everything. So that is 20 multiplied by 10 to the power negative 3. It will give us, that is 0.01. Then once we divide that by 200, it will give us, that is just 10. It will give us 10 to the power 4, which is 1 times 10 to the power negative 4. Yeah, that is, it will give us 10 to the power negative 4, so which is simply 1 times 10 to the power negative 4. Okay, so we have our concentration there. Our volume, let's get our volume. So let me even change the color for this one so that we may know it. So our concentration, we have our concentration here. Okay, all right. So now let's look for our volume. So our volume, we also have our volume, which they've said if the color development is compared with the volume of 2.0 millimeters of standard methanol solution, so 2.0 millimeters is our volume. So the volume they've given us also, we can say therefore volume is equals to 2.0 milliliters. Okay, so let's now try to calculate the amount of substance or drug we are testing, okay, which is S. Okay, so let's calculate our S. So from the question, as we can see, this question is similar to question 1, which we looked at. So, you know, out of these 2 milliliters of ethanol was completely dissolved in 50 milliliters of water. Then from that 50 milliliters of water, we only took 1 millimeters, which we had used to separate. So what we can say is, out of 50 millimeters, we only took 1 milliliters out of 50 multiplied by the ethanol which we had used, which was 2 milliliters. So this one is in millimeters, this one is in milliliters, this one is in milliliters. As we can see, these millimeters and that millimeters will cancel each other. So once we multiply everything, we're going to get 1 by 2. That is 2 divided by 50. It will give us, that is 0. So meaning our S, therefore is equals to 0.04 milliliters. Okay, so we have everything. We have our data. So what we can do, so this is our S. What we can do to calculate for the limit, we can say a limit is equals to S multiplied by V over that one. And because our value shall not be expressed in percentage, that is why we've left out the percentage. So once we substitute all the values, then we're going to have our concentration, which is simply 10 to the power negative 4, our volume, which is 2. So concentration, which is simply just 10 to the power negative 4 multiplied by the volume divided by 0.04. And as we can see, our concentration here is in grams per milliliters. Then our volume here, which is also in milliliters. And this one on the bottom is still the volume. As we can see, our S is in volume, is also in milliliters. So what we can do on the units, we will see that this unit will cancel with this unit. Okay, so we can finally remain with only grams per milliliters. And that is what they also want from our question. All right, so let's calculate now the final value. So limit is going to equal to, when we multiply everything, that is going to give me 10 to the power negative 4 multiplied by 2, then the entire value divided by 0.04. Then we are going to finally have, which is 5.5 times 10 to the power negative 3. And this one is going to be in grams per millimeters. All right, so therefore our limit is equals to this value here. All right, so thank you for watching this video. Make sure to subscribe and hit the notification bell so that you may be notified every time we upload a new video. All right, So we'll meet in the next video. Stay blessed.